We're continuing the Python from Beginners course. At this point, we have installed the Python language itself and the Visual Studio Code environment together. Now it's time to take our first step into programming. To start, let's try to understand what computer programs can actually do. At its core, it all boils down to a few basic things: storing data, performing various arithmetic operations, checking logical conditions, and implementing loops. In fact, the logic of all programs is built on combinations of these fundamental building blocks. Together, we will explore each of them step by step, starting with the very first method of representing and storing data in Python. Let's talk about how data is represented in Python. Imagine we have some kind of object, a storage unit, if you will, that can hold either numbers, strings, or other types of data. However, this object can only contain one type of data at a time. For example, it could store a number or a string, but not both a number and a string together in the same object. In a program, there could be a huge number of such storage units. So, how do we access the specific one we need and retrieve its data? It's actually quite simple. To do this, we need a link to the object, and we access that storage unit using the name of this link, essentially the name of a variable. But how do we create an object with some content and a link to it? That's straightforward too. All we need to do is come up with a variable name and use the assignment operator, the equals sign, equals symbol, to specify the object it will point to. For example, a line of code like this creates an object that stores the number 9, and A becomes the variable name, the link that points to this object. Let's implement this in a program and see for ourselves that it works as expected. Let's switch over to Visual Studio Code. I'll write this line, A equals 9. By doing this, we've created a variable named A, and this variable links to an object with the value 9. To confirm this, we can display the variable in the console using the familiar print function. Let's run the program and see what happens. Sure enough, in the console, we see the value 9 appear. Let's dive a bit deeper into how Python works with variables and the assignment operator. Pay close attention to this assignment operator. It's the equals sign, equals, which in programming connects the operand on the left with the operand on the right. For instance, a line like var_a equals Atom creates a variable named var_a that links to an object containing the string Atom. Notice that this line actually creates a new variable called var_a. Before this, it didn't exist, and we can't access variables that don't exist yet. Imagine if we tried to write print var_a right away without defining it first. The Integrated Development Environment, IDE, would immediately flag this non-existent variable, underlining it to warn us. Let's run the program anyway to see what happens. Sure enough, we get an error saying that var_a is not defined. This shows us that to use a variable in a program, we first need to create it by assigning it a value, like the string hello world, for example. Once we've done that with a line like var_a equals hello world, the variable var_a exists, and we can use it without issues. If we run the program now, there's no error, and we'll see outputs like the number 9 or the string hello world in the console. Now, what if a variable like a already exists? Can we assign it a different value? Let's say it starts with a equals 9, an integer, and then we write a equals 3.6, a floating point number, a decimal. This changes the type of data from an integer to a float. Can we do this? And what will a equal now? Let's run the program to find out. It works perfectly, no errors, and now a holds the value 3.6. Here's what's happening behind the scenes. Originally, a linked to an object with the value 9. When we assigned it 3.6, Python first created a new object storing 3.6, and then it was updated to link to this new object. If no other variables link to the old object, the one with 9, Python's garbage collector automatically removes it from memory. That's how Python manages things. Notice something interesting here. It started as an integer, whole number, but after assigning 3.6, it became a float, decimal number. In Python, a variable's type is determined at the moment of assignment. This is called dynamic typing, as opposed to static typing, where a variable's type is fixed when it's declared, like in languages such as C++ or Java. Let's explore the assignment operator further. What happens if we assign one variable to another, like b equals a? In this case, both b and a end up linking to the same object. For example, if a links to an object with a value 9, after b equals a, both a and b point to that same object. There's no copying or duplication of the object itself. Only the link is copied. This is a key concept to understand in Python. Variables don't store values directly. They link to objects that hold those values. This flexibility is why we can assign all sorts of different data types to the same variable. For instance, we could start with b equals some string, then reassign it to b equals 0, an integer, and later to b equals minus 3.7, a float. Python handles this seamlessly thanks to its dynamic nature. Let's keep this in mind as we continue. It's a fundamental part of how Python works. Let's continue exploring variables in Python. If we print the variables a and b, we'll see values like 9 and minus 3.7, respectively. The ability to assign different types of data to the same variable is incredibly convenient. However, it's crucial to remember that a variable is just a link to the data, not the data itself. Sometimes in programs, you might come across what's called chained assignment. This is when multiple variables are assigned to the same object in one go. For example, writing a equals b equals c equals 0 creates a single object with a value 0 and all three variables, a, b, and c, linked to it. If we run this in a program, we can verify this behavior. Python has a handy function called id, which returns the unique identifier of the object a variable links to. Let's print the ID of a, b, and c using print. When we run it, we'll see the same number for all three, confirming they all point to the same object. But what if we want each variable to link to its own separate object? That's where multiple assignment comes in, written like this: ab equals 1, 2. Here, a links to an object with the value 1, and b links to an object with the value 2. If we check their IDs, they'll be different, proving they're distinct objects. This technique is also great for swapping values between variables. Say, a starts as 1 and b as 2, and we want to flip them, so a becomes 2 and b becomes 1. We can do this easily with a, b equals ba. Running the program and printing a and b will show 2 and 1, respectively, with no errors, and their IDs will reflect the swap. We've already seen that variables can link to different data types thanks to Python's dynamic typing. But how do we check what type of variable is linked to? Python provides the type function for this. For example, print type a might output class indicating that it links to an integer, like 2. Let's try it with more examples. Define x equals 4.6, a float, and s equals hello world, a string, then print type x and type s. You'll see class float 4x and class str 4s. At this stage, you might wonder, what data types exist in Python? I could list them all, but that'd be overwhelming right now. Instead, we'll explore them gradually throughout the course, building your understanding naturally. So far, we've covered 3 types: integers, int, floating point numbers, float, and strings, str. Now let's talk about naming variables properly. Here are some simple rules. 1. Variable names should be descriptive, indicate their purpose, who, what. 2. Variable names should consist of meaningful and readable words. 3. Variable names in Python prefer singular, lowercase words separated by underscores. For example, message equals message or count equals 0 are clear and valid names. Note that arg equals 0 and arg equals 0 are different variables. Python is case sensitive, so an uppercase arg and a lowercase arg are treated as distinct names. Also, you can't use Python's keywords like true, false, or if as variable names. Try writing false equals 10, and your IDE will flag it as an error. To see all keywords, run help keywords in Python. You'll get a list like false, true, for, etc. Avoid these. Similarly, don't use names of built-in functions like print. If you write print equals 5, print becomes a variable, not a function, and trying print 5 will fail with an error. Built-in names like print, max, or len are highlighted in IDEs, often in a distinct color like blue, so you'll know to avoid them. Over time, you'll memorize common built-in names and keywords, making it second nature to pick safe, meaningful variable names. That wraps up this lesson. I hope you now understand what variables are in Python, how they link to data, and how the assignment operator works. To solidify this, complete the practice exercises and move on to the next lesson. Happy coding!